So back to these Lewis structures, or now they're calling them Lewis symbols. We are interested in the valence electrons. The valence electrons are in the outermost principal energy level. They are the most loosely held, and these are the electrons that are interacting with other atoms. These are the electrons that are involved in bonding. So in a Lewis symbol, we are just going to show the valence electrons. So here is the electron configuration for oxygen. In blue, these are core electrons. We are not concerned with those. We're looking at the valence electrons. There's 6 valence electrons. The highest shell is 2, and there's 2 in the S subshell and 4 in the P subshell. And so we're going to represent those in a Lewis symbol as dots around the valence start over. Just lost it. Completely lost it. We draw the dots to represent valence electrons. We draw them around the element symbol. That's what that is. It's an element symbol. And we've got top and bottom, right and left. You can have a maximum of 2 electrons in each position. So maximum of 2 per side. And this is a very simple way to visualize the number of valence electrons. It's a little bit like looking at dice. You can look at dice and you don't actually have to count the spots. You recognize that when you start playing Monopoly with a kindergartner, right? And they've got a 5, and they're counting the dots with their finger because they haven't recognized that pattern yet. When we look at Lewis symbols, because we've got 2 on the top, 2 on the bottom, 2 on the right, 2 on the left, we can very quickly see, does this atom have 8 valence electrons or not? We call 8 valence electrons an octet, just like 8 people singing together is an octet. Octets are particularly stable. We've looked at the electron configurations and how the noble gases have 8 valence electrons. This is a low potential energy situation. That's good. Helium's an exception. He's one of those little guys. He has a duet of electrons. And then hydrogen is even smaller than helium. Hydrogen doesn't even try to get an octet. He's just trying to be like helium. So the octet rule states that atoms transfer or share electrons to achieve an octet of valence electrons. So if it's a metal nonmetal, the metal's going to give up electrons to the nonmetal until they both have 8 valence electrons, an octet. If it's 2 nonmetals, they're going to share in a way that they both have an octet of electrons.